Greetings, Warhawk Geometry. This is Mr. Walker with your 2.5 notes. We're going to be working on reversed conditions. A reverse condition is called a converse. You're going to be able to write converses, understand them, and then we're going to take the theorems that we learned in 2.4 about our angles with two parallel lines, our alternate interior, same side interior, exterior, and our corresponding angles. And we're going to use those with what converses are. First off, let's talk about what a converse is. Before we begin into that, we talked about what a conditional statement was. Remember, a conditional statement is an if-then statement. It starts off with if the hypothesis, then the conclusion. Remember, we represented a hypothesis with the letter P, as you see here, and we represented the conclusion with the letter Q. So I've given you a conditional statement right here. Remember, the hypothesis is after if, the conclusion's after then. On your own sheet of paper, see if you can identify for this statement, if a figure is a square, then it has four sides, the hypothesis and the conclusion. All right, you should have got for the hypothesis is a square. If you put a figure, that's okay, but you're not going to use that in this scenario. And for the conclusion, you should have got it has four sides. So this would be my P, and this would be my Q. All right, now that we know what our conditional statement is, and we've identified its parts, we are now going to work with the converse of this. We are going to take our statement and we are going to transform it into the converse. So here's our conditional statement. If a figure is a square, then it has four sides. We are going to flip the position of our hypothesis and our conclusion. Here's our converse statement now. If a figure has four sides, then it is a square. Notice that we switch the position of our conclusion and our hypothesis, better known as P and Q. So a converse is basically the reverse of a conditional statement. We switch the place of the hypothesis and conclusion. And here's the statement we would use. We are going to be working with converses from everything we did in section 2.4 for our theorems. In section 2.4, we learned these theorems right here. We learned the corresponding angles postulate, the alternate interior angles theorem, alternate exterior angles theorem, same side interior angles theorem, and same side exterior angles theorem. And each one of these theorems and postulates, the given was this picture here. And this picture had two parallel lines, and I'll make them parallel by giving you the arrows. Couldn't do that on my computer. They gave me two parallel lines cut by a transversal. And since they gave me two parallel lines, I drew the conclusion that angles must be supplementary or complementary. Remember, our same side are always supplementary. The other ones are always congruent to each other. That's only when lines are parallel. Now we're going to be working with the converses. The converses are the exact opposite. And in this scenario, they're going to give us two lines cut by a transversal. Notice it's just two lines. It doesn't say anything about parallel lines. However, they're going to tell me that the angles are supplementary or congruent. So notice we flipped it. What our conclusion was last time is now our hypothesis. And since that's the flip, we're going to take our hypothesis from before and make it our conclusion. So now they're telling me that the angles are congruent and supplementary. The conclusion we're going to draw is that the two lines have to be parallel. Please make sure you copy down the notes of what those theorems and postulates are.
After to measure each angle